Hey there, I'm back. We're in Ignite Australia in the Gold Coast, as I was told. It's beautiful here, it's lovely, it's sunny, and I have a special guest here with me, Lofranco. Did I say that right?
Yes.
Okay, are you sure I said it right? Because you're not just me. Okay,
Nah,
tell us
that's
who you
correct.
are and what you do, my friend.
Cool. So I'm a senior data specialist working for Empard, which is a Microsoft consultancy, effectively with offices around Australia. So I'm a part of the data insights team, which obviously does traditional data warehousing along with advanced analytics stuff. So big data, Azure machine learning, and that sort of stuff.
So that's awesome. I looked through some of the work that you've done, and I'm going to start with how did you get on this path, number one, and how did you learn all this stuff? Because I saw how you did it, and I'm
Right.
like, I don't have the attention span to be as smart as you on how you learned it. So tell us how you got into it. What made you decide to do data science?
Right. So effectively, I started my career as a dev. So I did heaps of C#, ASP.NET, lots of web application development, some Node.js, JavaScript. And then I got involved in a financial sort of system where we're doing a lot of volatility models, Monte Carlo simulations, where we're effectively looking for arbitrage opportunities
Sure.
in stock options. And that I thought was really interesting. At first, I had very little knowledge of the different algorithms we were actually implementing. So I did a lot of self-learning, did heaps of online courses, EDX, Coursera, that sort of stuff. So pretty much learned on the fly as I went. And
Yeah, but how do you go from like Monte Carlo simulations and arbitrage settings from a regular develop? Like, did you know what they were talking about?
yeah, I have an idea of what they were.
Okay.
But once you dig deeper, you sort of, so the way I learn is I would attack it from what I need to do, so what the goal of the solution is. And I would run into many concepts which I wouldn't know, and then I would just kind of push through that concept. So if I'd say, what is an arbitrage? Okay, arbitrage, you have to know these three concepts. And then let's say two of them I don't know, then I would dig deeper into that sort of stuff. So I'd almost structure my learning according to the goal that I'm trying to implement. And then I then dig deeper from there.
Holy cow,
So
she
it's-
should start a school. This is ridiculous. Like, it took me a long time I don't even understand Monte Carlo simulations all the way. I barely understand arbitrage. And what would happen is I would try to do something, I'd be like, let me learn this. But you're saying you were goal-oriented in the sense
Yeah.
that you had a project you worked on,
Yes.
and you had to figure it out.
Yeah.
You must have worked in a really cool environment to do that.
Yes, I had a very, very supportive mentor. So having a mentor is definitely very helpful in the sense that you have someone to ask when you're lost. So that's definitely something that helped me in the journey. I reckon if I didn't have a mentor, I would probably be way further from what I'm now. So,
Sure.
yeah.
So you mentioned that you had certain problems and you sort of just went headlong into it. Any concept you didn't know, you went and found out about.
Yeah.
You also did a lot of these edX and Coursera courses. Tell me about that. There's got to be some kind of discipline. Like, how did you discipline yourself to do that? Is it just do it?
I reckon if you really enjoy it, it's not, if you enjoy the things that you're actually doing, it's not something you sort of force yourself to do it if you're having fun. So if the things that, I really thought the financial algorithms were quite interesting, personally, so it was more of a curiosity sort of drive, more than anything else, than something that, I need to do this because of Project X. So because of that, I didn't really have that much of an issue of dedicating a lot of time to it.
I see.
So if you really enjoy it, I reckon it's you tend to find the time to actually go and sit down learning the things.
So it was both this is super interesting and it became a hobby kind of thing because you really
Yeah.
liked it as well. And it just so happened that your work required you to know these things
Yeah,
too.
it makes sense if you're doing a project around it because a lot of the times you do tutorials and you're sort of, okay, what's next? And you don't exactly know what's next. But if you have a project, you're building something, you have a goal in mind, it drives your learning a little bit more concrete because you see the fruits of your labor as opposed to, I want to learn X technology just because. So then you don't really have direction of what you want to achieve with it. But if you have a project, all of a sudden, I want to learn X because I want to build why.
I see.
Yeah.
So let's just say somebody is getting started in data science. What kind of projects should they dive into? Like you mentioned arbitrage and fintechs type stuff.
Right.
But what is like something anybody could jump into as a project that would help them get into these concepts?
Right. I'd first start off with the fundamentals of machine learning, like why, more of a why you would do it than anything else. Like, why is machine learning better than the traditional programming step X, Y, if and else statements?
Sure.
Why would a model that learns why is that more efficient or more long-term, more accurate than the traditional ways of programming it, artificial intelligence, if that makes sense. And also obviously the process of a data scientist. And then from there, you'd probably start off with some of the fundamentals like linear algebra. You definitely need a pretty good grasp of linear algebra. That's seen across the different machine learning models.
Sure.
But from the fundamentals, you also, right now, there's also a lot of tooling that's available to you that you don't, I wouldn't say you don't need to know it, but to get started as a complete beginner, you could just fire up Azure ML and then see, if you walk through a bunch of tutorials and actually have something running pretty quickly, surprisingly, which would probably take a really long time if the tooling wasn't there in the first place.
So let me ask you this. What is the data, you mentioned a process or some kind of data science process.
Yep.
What does that look like?
Right. So there's a lot of, so I guess to understand the data science process, you have to have an understanding what it used to be. So there's a lot of traditional business intelligence solutions which basically tell you what is there. Like for example, I want to know how much retail sales. Now the data science process, you're effectively trying to take it a step further when you're trying to predict something or prescribe what's the best path forward. So a lot of the times, you're effectively exploring your data. You're not sure exactly which data would be relevant to your model. So there's this very, very fluid exploration phase in which you're building probably 10, 15 models before you actually say, hey, this is actually a workable model which we could deploy. And then from there, you would then deploy your model using some sort of orchestration or operationalize your model using some sort of orchestration tool, such as Data Factory.
Sure.
And then, yeah.
So you mentioned, and this was interesting, right? Because you said you're going to build 10 to 15 things before it works.
Yes.
So I feel like this is something that's not talked about enough, right? Because everyone's like, oh, the data scientist has the corner office and they shut the door and I don't know what they're doing, right? What is it that data scientists are doing? And I want you to talk about specifically those 10 to 15 models that didn't work. What does that look like?
Right. So, well, it comes from like you said, the data science goes and locks himself in the office, but it's not really the case. He has to have lots of business knowledge around the domain you're doing. So when you're doing the entire modeling process, you're structuring your data in a way, you're weighing different, let's say, coefficients in your linear model, or you're trying a different algorithm which would then result into a better accurate model. There's a lot of effectively mix and match of the models that you're trying to build. And you also have to take into account what is more important to your users. Is the interpretability of your models very important? Let's say a linear regression model is very interpretable. You know, this coefficient would affect the results because of, if you weigh this, the weight tells you exactly if everything's held constant, then the result would change by the coefficient.
Yeah, right.
And then you have a neural net model where it's a bit of a black box. It's like, I don't exactly know what the model did underneath the covers that created this outcome, but all you care about is the accuracy. So there's this massive weighing of, should I actually build a interpretable model from a business standpoint, because the business wants to know what the inner workings of the machine learning model, versus a black box where all they care about is accuracy of the model. So there's that entire balance of that. So
yeah, it's an interesting thing because like you bring up a really good point of like, there's models to do prediction and there's models to do exploration, and sometimes you're going to do a lot of exploratory models, maybe some predictive models, just to figure out what data you have. Would you say that's the case?
Yeah. So there's a lot of models that are not even predictive in the sense that they just effectively change the data in a way which will be consumed by another model.
Like PCA, for example.
PCA, yeah, like, or clustering, or let's say you want to just cluster your data and see any generic patterns in the data, which would then feed to a different model.
I see.
So, that would effectively be your feature engineer, another feature within your feature engineering process.
So there's an interesting thing you said to me, that data engineering / feature engineering. This is a lot of the sort of pre-work that you do when you're doing modeling. Can you talk a little bit about that? Because there's obviously different kinds of data,
yes,
and you have to treat these different kinds of data differently, and then you got to somehow put them into the modeling part differently. Can you talk about that and give us a sense for what does it mean to do data engineering?
Right. So there's a lot of the surprisingly, a lot of the work is actually getting the data in the right form.
It's like janitorial data work, right?
Exactly. Like they call it the data munging process, and a lot of folks only see the sexy part of the models, but really there's a lot of work just getting the data in the form that the model can consume, such as effectively ironing out all your features. So there's a fair bit of work in the entire pipeline where you're actually just cleaning your data. You're just effectively taking out any outliers if you have any bad data within your data set, or if any points that doesn't make sense. A lot of the data that you collect in your so-called data lake are very raw. So you might want to clean the data, join it across different data sets to expand your feature set. So there's heaps of other steps that needs to happen before you actually start modeling your data.
Yeah, and that's the thing, right? I love the modeling part, but there is tons and tons, as they would say here, heaps. That was for you, Kotsi. Heaps of work to do, and it's literally like janitorial work. And if you work at a bank, it should be called a dirty job, because Jim is always putting age in the name field. What do you do with that kind of data? Right?
Exactly.
So the other thing I wanted to talk to you about was there is this really interesting architecture called the Lambda architecture. I wanted you to elaborate on that to give us a sense for there's not just having data, but there's different kinds of data. Will you talk about that a little bit?
Yep. So the Lambda architecture, well, first off, there's a lot of different architectures but the Lambda architecture is the very popular one that lots of people use. So the Lambda architecture is composed of 3 layers. You have your batch layer, your speed layer, and your serving layer. So the entire point of the batch layer, as you'd imagine, is having batch processing. And then speed layer is all about getting your data from point A to point B, which is your user, the fastest. So your speed layer would probably have some sort of lightweight analytics. In Azure, you'd use Stream Analytics. In Spark, has Spark streaming, that sort of stuff. And you're only acting upon a sort of window of your data set, which you run your predictive models or whatever analytics you have. And then you surface that in a sort of view to the user. The batch analytics, you effectively run your models across your entire data set. And then that also goes into the serving layer. And then your serving layer is all about mashing those 2 views together so that when the user views your application or your dashboard or whatever you use to surface the data, it has a holistic sort of view of what's happening. You have real-time information and analytics, but at the same time, this gets updated in a very regular interval by the batch layer, so it becomes more accurate as it goes on.
Can you give me an example of something? And I know I'm kind of putting you on the spot. Is there an example of something that you could sort of see all of the 3 elements involved? That way people get a sense for the speed layer, the batch layer, and the serving layer?
Yeah, so I've actually been involved with a project. It's a remote monitoring and predictive analytics project.
Is this the one you're doing at your talk?
This is slightly. This is for I did build this for a client.
Okay, let's hear about this one.
Yeah. So effectively they had a bunch of temperature sensors that they rigged up in effectively on the client side, and they're monitoring a bunch of telemetry of their machines and fridges, and they want to be able to detect which freezers. Because there's food in the freezers.
Of course.
Yeah, so which freezers are effectively acting strangely, which would require maintenance or which would require attention of the staff. So effectively, we're taking all this telemetry temperature sensor, pushing it to IoT Hub, which is our ingestion point. And from there, we have two paths. We have a stream analytic job that dumps it into blob storage. So this is our archival sort of data layer. And then another stream analytics job that pushes straight into Power BI, along with doing some sort of aggregation of your data and some sort of real-time alerting. So we have some thresholds saying, okay, if the temperature goes over X threshold, send an email or that sort of stuff. And then that goes straight into a dashboard. We have a Power BI dashboard and a web application that we use to surface the data. So that's the speed layer that we're talking about. While the batch layer, we have an actual Azure ML job that we trained, which essentially, as the telemetry comes in, we take windowing. So we say, take the last 4 days, 3 days, and last 4 hours of the data, we use that as features in our model, and then from there we could predict which freezers and fridges and appliances are acting strangely, and this gets surfaced in the same serving layer, which is the application or the Power BI dashboard.
So the batch layer is where you're doing sort of this prediction of what needs maintenance,
right,
more or less. And what's happening as the stream comes in, you're passing some of those data into the models to do prediction on which ones, and then those get served into the Power BI dashboard.
Exactly, yeah.
I see.
Yeah. In fact, like at the time, Azure Stream Analytics couldn't call into Azure ML directly, and I believe right now there's already a feature where you can actually call your Azure ML as part of your Stream Analytics job. So that would have been also even more interesting, because then now your Azure scoring job is part of your speed layer.
So let's talk a little bit, because we've talked a lot about the data science process, sort of the dirty work that you do.
Yeah.
We've also talked about a concrete example in the Lambda architecture of the speed path, the batch path, and the what was the last one?
The serving layer.
The serving path,
yes.
That's right. Let's talk about some of the tools that are making this all a lot easier.
Right. Cool. So like I mentioned, Stream Analytics. So Stream Analytics is a very great way to get started. Very easy to work with Azure. If you want more control around your data, there's Spark streaming, and the Hadoop ecosystem offers a heaps of other areas in that speed layer. In the batch layer, in Azure specific, there's Data Factor, which you could use to orchestrate all kinds of jobs. So for example, if you have a Hive script that does your feature engineering, or let's say you have a USQL script that acts on your data lake, where your data stands, Data Factory can orchestrate all of that. And then effectively, and at the end of your pipeline, you'd imagine have a job which would then move your processed or scored data sets into your serving layer, which could be a SQL Azure database, a DW, or even Power BI.
Every time I hear about these things, they always have this really complicated diagram.
Right.
So let's start with some of the pieces, right? Because
Right.
I think if we understand the pieces, then everything starts to fall around it.
Yep.
What do you think is the most important piece that one should understand in order to get this whole architecture to work?
Right. I'd say, first, obviously, you need to understand why the architectures, how the entire layers, what the roles of the layers are
Right.
there for. And after that, you need to know the actual services that actually do the individual components within the layer. So you need to know what is HD Insight all about? What is Stream Analytics all about? What is blob storage and data lake store all about? So in order to actually build the pipeline, you have to have a fundamental knowledge of the different components that are out there.
Well, we have 8 minutes, right? You think that's enough time? let's She's like, well, no, I've literally spent the last couple of years of my life trying to understand this. And so let's start with HD Insight. Is that
Right.
just Hadoop on Azure?
Yes, so it's effectively a platform as a service offering of Microsoft of Hadoop Hortonworks HDP application on Azure. So yeah, so it's 100% the Hortonworks HDP, so anything you can do on that platform, you can do on HD Insight.
Now, is that, like, I've always understood Hadoop to be a distributed file system.
Right.
But then you put stuff on top of it, right?
Right, yes.
Is that stuff, can you do that on Azure as well? Does that become part of the architecture that you set up?
So HD Insight, HDFS in particular, is only just a file system. in HD Insight specifically, they've actually abstracted the storage and the compute layer. So your storage is actually blob storage.
I see.
So which is great because then you can actually delete your cluster and still preserve all your data. As opposed to, let's say, if you deployed your cluster in an IaaS setting where you actually have a VM, 100 VMs as your nodes, and say if you deleted your VMs, obviously all your data goes away.
Or your name node gets blown up and all the files are gone.
Exactly. So by having blob storage as effectively HDFS, it decouples your compute, and now all of a sudden you have this flexibility of actually deleting your cluster if you're not using it. And if you spin it up again, as long as you have your metastore in a separate database and your blob storage right there, you can just point that to your newly provisioned cluster, and you'd have almost pretty much, you can pick up where you started at.
So I hear the term data lake, right? And
Yes.
I'm guessing, does that have something to do with HD Insight? Is it a different thing? Is it working together?
Right. So a data lake actually is, you could think of it as Azure's HDFS as a service. So blob storage has some limitations. Like I believe you can only put so much in blob storage before it starts complaining.
Getting angry.
Yeah. So Microsoft's entire promise with data lake is it's unlimited. So it's petabytes.
Well, in theory, right?
In theory,
Yeah.
it's petabyte scale. So I'd imagine you don't reach those limitations in data lake as you would in blob storage. It has also a lot of more security as opposed to blob storage. Blob storage is a very simple security module. You just have you have 2 keys, and that's pretty much it. And data lake has all kinds of other things like ACLs and role-based access.
So that would be a Hadoop kind of instance, but with better guarantees, better security.
Right.
So it's not HD Insight, it's like the better HD Insight. Would you say that?
I'd say you could provision HD Insight using Azure Data Lake Store as your primary storage.
I see.
You can also provision it as using Blob Store or Azure Data Lake Store. You could also add blob storage as a secondary blob storage of your container. So say you have data already sitting in blob storage, you don't necessarily have to move that across Azure Data Lake Store. You could still add that as a secondary container.
I see, because since it's a virtualized HDFS, you can sort of add storage mechanisms to the back.
Right. You still need to have a default sort of storage account that could be effectively your Azure Data Lake Store or blob storage.
Well, dang, we're running out of time, and I have 1,000 more questions. So now that we've talked about where the data goes, is Stream Analytics the ingestion point, or is it IoT Hub? What are those two things in relation to each other? Because I feel like there has to be a way to get data into the data lake.
Right. So for an IoT setting, IoT Hub is definitely your first class, sort of first go-to ingestion point. So it's effectively a large, at the end of the day, a very large queue with lots of other different functionality, such as bidirectional communication. If you're not really interested in the bidirectional communication, you can go for event hubs, which is also very, very robust to high peak loads of ingestion loads. And then from IoT Hub, you'd probably have some sort of something consuming from the IoT Hub, such as Stream Analytics.
So it's just like a queue.
Yeah, it's a very, very robust, highly scalable queue.
And then Stream Analytics takes the messages on the queue and does something with it. It will either put it into the batch setting or put it into HDFS and then go into the speed path as well.
Right, exactly.
So what does Data Factory do? Is that what orchestrates all the movement of data from the queue to data, Stream Analytics, etc.?
So Data Factory is more around the batch layer. So we talked about the speed layer and the batch layer.
Makes sense.
So Data Factory's entire role in the entire Lambda architecture is more in the batch. So you'd have some pipelines that are scheduled to run per hour, per day, per week, and that sort of stuff.
And so that would be on the batch layer that you would do Data Factory, and that would be orchestrating, looking at making the models, for example, in Azure ML, that later Stream Analytics would consume.
Right, exactly.
Okay, well this is good. Anything that we've missed?
I think...
She's like, let me see.
Yeah, there's a fair bit. There's a lot of other things that you could do. We haven't even touched Spark or say even the serving layer, all the different ways you could expose your data. Like Power BI is such a very powerful way of actually graphing your data, visualizing your data.
And Power BI would be considered on the serving layer, correct?
Yes.
Okay.
So it's more of a visualization of your serving layer.
I
So.
see. Well, we are about out of time, and I feel badly because this has been super informative. I wish we could have more time. Hopefully, maybe we'll get to talk to you again soon. But we've been learning all about sort of the data science stuff. Tell us more about you. How can people get a hold of you if they have any questions? Do you have a blog, etc.?
I don't have a blog, but
You should.
yeah, right.
She knows a lot of stuff.
Yeah, so you could get a hold of me by LinkedIn. So you could just send me a message in LinkedIn. And
Fantastic. Well, this has been very informational. Thanks for spending some time with us. Awesome. Thanks for watching. We got one more session coming up. Architect Robust Big Data Solutions with Azure Data Lake. Wow, that works out. So please stay tuned for that, and we'll catch you after the break for the closing ceremonies for us here at Channel 9. We'll see you.